Hey guys, this looks like a fun one. We have an equilateral triangle right here. We're given that the area of this smaller circle is 105 meters squared, and they want us to find the area of the larger circle. If you want to try this on your own, pause it, because I'm going to solve it in 3, 2, 1. So first I'm thinking, since it's an equilateral triangle, we know that each of these angles is equal to 60 degrees. If we find the center of these circles and drop the angle bisector to that point, it's going to cut this 60-degree angle into two 30-degree angles. And next, let's connect this radius from here to here. Now let's label it R since it's the radius of the smaller circle. This side of the triangle is touching this circle in one point. That means this is part of the tangent line. And at this point of tangency, it meets at right angles to the radius. And now if we focus on this triangle right here, the sum of the interior angles of any triangle is 180 degrees, which leaves us 60 degrees for the last angle. So this right here is a special right triangle. It's a 30-60-90 triangle. In every 30-60-90 triangle, the hypotenuse is always twice as long as the smallest side. So if we rotate these notes, we can match this with the orientation of this triangle up here. So once again, the hypotenuse is twice as long as the smallest side. So for this one, this hypotenuse needs to be twice as big as this side. So this is going to be 2r. And we don't need these notes anymore. Well, let's take these two things and copy them down here. So let's focus on the small circle area. Let's gray out all this stuff. The area of a circle is pi times the radius squared. Well, in this case, it's going to be pi r squared. So now we can focus on the larger circle, so let's gray out all of this stuff. The area of the large circle is also going to be pi times the radius squared, but the radius for this one is 2r. Let's get rid of the question mark. We can bring over the pi. This 2 is going to get squared to give us 4, and r is going to be squared to give us r squared. So now we have pi times 4r squared. We can swap it to be 4 times pi r squared. And we already know that pi r squared is equal to 105 meters squared. So I'm going to substitute in for this pi r squared, 105 meters squared. And then 4 times 105 is 420. So the area of this larger circle is 420 meters squared. And that's the answer to our question. We can put a box around.